Have you ever been so cold that you book a vacation somewhere warm only to come home to a busted water pipe in your basement? And then you say to yourself, I'll bet I could build a cheap water notification system on my own. Well, then this video is for you. We're going to walk through the basics of putting together an inexpensive water sensor and some Python on a Raspberry Pi so that you too can get a text and an email whenever there's water in your basement. For this project then, you'll need a Raspberry Pi, and any Pi will do, from the earliest to the latest, including the tiny little 0 line. You also need some sort of Raspberry Pi water sensor. If you search online, you'll start to see a lot of the same stuff over and over. Here's the one I chose, because I can usually get a 5-pack of these for around $20 US. And whenever I have seen these available online, they always come in a package like this. 2 sets of wires, a controller, and a blade. Putting it together is relatively simple. The blade in the 2-wire set connects to the pair of pins on the controller. The controller will connect to the Raspberry Pi with the 3-wire set. This particular controller, which is very common, has a power in called VCC, a ground pin, and then 2 different kinds of communication. The AO, or analog out pin, communicates how much moisture exists between the 2 tines of the blade. The DO, or digital out pin, communicates if moisture exists or not. And really, this is all we care about in this project. Is there water or not? So we're going to use the DO pin. Searching online, you can easily find images of what each pin on the Raspberry Pi does. The water sensor I'm using, again, has power in, ground, and digital out. I'm going to just choose some of the pins up top because this right now is the only controller I'm connecting to the Pi at this time. So I'll use this first GPIO for communication, pin number 3. I'm going to use pin number 4 for power and pin number 6 for ground. And this is how it looks on my Raspberry Pi. Pin 3, pin 6, and back there is pin 4. Altogether, we can see the 2 wires go from the blade to the pair of pins on the controller. The VCC pin, the voltage from the controller, goes to pin number 4 on the Raspberry Pi. The ground from the controller goes to pin number 6 on the Raspberry Pi. And the DO pin on the controller goes to pin number 3 on the Raspberry Pi. I'm making this video in October of 2022 on a Raspberry Pi using the latest Raspberry Pi operating system. These come with Python version 3.9.2 at this moment in time. Really probably 3.6 or higher is great. And for this project, in order for the Python code to be able to talk to those GPIO communication pins on the Raspberry Pi hardware side, we have to install one more package. This particular package is called Python 3.rpi.gpio. Once that's installed, our Python will be able to talk directly to the pins. So how do we use these GPIO pins? Let's go online and just simply search for rpi.gpio. This takes us quickly to PyPy. I happen to have been here before. There's this excellent examples and documentation link from the creators of the package. So we're going to go there and just jump right into basics. The first thing we do is import the rpi.gpio package into our code. So let's do that now. Water.py. And there we go. Now we can have access to those GPIO pins. The next thing the site shows us is that there's 2 ways of numbering I/O pins, board and BCM. BCM uses these kinds of numbers, GPIO 2, 3, 4, 17, 27, 22, and board uses the physical numbering that you find here on the outside of this particular image. 1, 3, 5, 7, 9, etc. odd on the left, even on the right. I'm going to use the board numbering because in my head that's easier. Choose whatever works best for you. So let's head back to this page and find out how to use board. So we have to set the mode for the GPIO module to be board. Awesome. So let's keep going. Setting up a channel. They use the word channel. I like to use the word pin. So we're going to use this right here. This is really close to what we want. GPIO set up our pin to be an input. We're taking input from the water sensor as opposed to output. So I'm just going to take that. I'm going to insert it here. And this is more my style. You can obviously do whatever you like. I like the word pin. So in this particular situation, we're using that DO line that's connected to pin number 3. I like using variables like this. It tends to make it easier for me to code, but feel free to do whatever you wish. So let's head back here. We're going to head down to the input section. There's lots of great examples in here. There's a lot of great examples, actually, and all kinds of stuff. So I'm just going to show you the one that I have found to be the easiest to use, and that's to use this event detect, and then we're going to add callbacks. Okay, so it's going to look something a little bit like this one right here. So let me grab this first line, come back in here. Again, I like using the word pin instead of channel, whatever you wish. There's 3 kinds of detections that the GPIO module can do: rising, falling, or both. Honestly, with my experience, the easiest is to just simply do both. I have not had really good luck trying to figure out how to use rising or falling in particular, so I'm just going to stick with both. There's one more item elsewhere in the documentation you'll see, and it's called bounce time. What this basically says is don't send a notification to my Python code except once every 300 milliseconds. Sometimes things get a little finicky, wires get a little crossed. This keeps it from being too chatty. Let's come back over here, and we're going to add an event callback, and I'll explain then how all of this works. Paste this in here. I'm going to come back, change the word channel to pin. And let's just call this notification function. All right. So what we're doing is we're telling the GPIO module inside of our code to detect an event whenever our pin goes from high to low or low to high, whether it's sensing water or not sensing water. You're going to see later that that's not as obvious as it can sound. And we're going to say, please don't do that, but once every 300 milliseconds. But when you do have an event detection from high to low or low to high, call this particular function. All right, so let's go back up here because in Python we have to define our functions before we can use them. So we're going to call this notification function. If you come back over here, when you look around at the code, the notification function does take, again, this channel concept. So in this case, just for the ease of seeing, what's the incoming pin? And let's just do something simple. Let's get the value. So you can, again, read all this in documentation. But basically it comes down to calling the GPIO module input function, giving it a pin, and that stores the value in our variable value. And then we're just going to print it out to the console for now. Incoming pin number in pin is now at value. I like white space a lot, so new lines. Bang. Let's come down here real quick. We're going to add, print, this is our starting value of the pin number pin is, and we're just going to jump that whole GPIO input right in here. GPIO input pin, curly brace, more white space. Awesome. So here's one little trick we can do to just give ourselves a time. We're going to make this a long-running task. So we import time, and then we're going to do while true, just an infinite loop. And then rather than just, waste processor time, we're going to sleep for some time. Awesome. So let's watch this thing in action. Python 3 water.py. Great. Starting value of pin number 3 is 1. If you're using what is technically a moisture sensor like I am, you'll probably have to calibrate it. To do this, start by keeping the blade dry, then use the controller, this tiny little dial right here, and turn this calibration dial until only the power light is lit up. Then turn the dial so that the other LED right here is also lit up. Then turn back slowly until only the power light is back on. At this point, try putting the blade into a cup of water. If you see the second light light up, you're pretty close to calibrated. If not, you'll have to use even more precise calibration, being sure to test always with a dry blade and then put it into the water. You'll need to note the value that is on your screen when the water is sensed. You can see here when I do not have the blade in the water, the value is 1, which means for my setup, 0 is when the water is being sensed. So let's go back and add some code. The way I like to do this is I'm just going to call it the on value. So for my setup again, on value is 0. Your mileage may vary. And so what I want to do is use this value so that we are only notified when water is sensed, not when it's not being sensed. So I'm going to come in here, I'm going to add if the value is the same as the on value, then go ahead and tell me something. Python 3 water, so here I am. I'm going to put this into the water. There are a lot of fun options for how to notify yourself of water in your basement. Email, text, loud buzzers, IRC chatbots, really anything you can think up. You're going to see how easy it is to use the GPIO module to add various notifications to this project. If you go to my code that is linked in the description of this video, you'll see I'm using SendGrid for email notifications. I also have another example in here that uses Twilio for sending texts. Between the print, SendGrid, and Twilio examples, I think you'll find that creating and then adding additional notifications is rather straightforward and very Pythonic. SendGrid comes with a nice, powerful library. So let's install it. Install SendGrid. I've already taken the liberty of copying my code from the repo into this particular Raspberry Pi. You'll notice that the way I have this set up is to use environment files. So just to keep this demo going, I'm going to go ahead and source that to get those variables into play. Now, let's take a look at this particular email notification file. You notice there's really just one function called send email message. I've already come back through, added the pin and the on value that we identified earlier in this video. So now, all we need to do is add this send email notification file and its function into our existing code base. You'll also notice if you look in the code base that I have it so that it only sends email notifications once every 5 minutes, because it used to be back in the day that I had to pay for every email and text. SendGrid does a good job, and so does Twilio, of making this really inexpensive, if not totally free. I'm going to copy it from here just so you don't have to watch me type ad nauseum. So this is our import statement. I'm going to put that back in here. And if we look at the other file, we can see this is a method name. It's also up here. So what we're going to do is we're going to simply copy this event callback and add just one more callback. You can add as many callbacks pretty much as you want. So I'm just going to copy this whole line. Can come here to notification function, which again is right here. I'm going to replace that with our new function. That did not work well at all. So let's just type it. Send email message. Awesome. So again, I've just taken this, copied it. There's one method, there's a second method. Yeah, let's see if this works as well as I hope it does. So Python 3, water.py, initial value is 1, and I'm going to put it in the water. Great. You can see the email came through. I logged that the message was sent. You can also see, again, that I have this only going once every 5 minutes. All right, one last tweak to this setup. What if I want the sensor to be really far away from the Raspberry Pi? I found that bell wire, typically just 20 gauge wire, works really well. Here you can see the blade I have right next to my hot water heater in my basement. There's the blade, there's the 2-wire set, and then the bell wire fits very nicely into the other end of the 2-wire set. I had to buy a few extra female-to-female breadboard jumper wires to connect the other end of the bell wire to the controller. And then, very important, I had to recalibrate. Using this approach, I was able to add 4 water sensors spread around the basement of my house. each time using bell wire to get the blade as far away as I needed, and each time having to recalibrate. To finish our project, we need to turn our script into a service that is run by the operating system on startup. In my code, online, you'll see a sample systemd file that you'll need to tweak to fit your context. You'll also see that it's set to restart the notification script should it ever stop running. If you go online and just simply search for Python 3 Raspberry Pi systemd, you'll come across some great resources. This is obviously the one I've chosen. You'll find that my script and code looks pretty similar to this. Each one of these is a great resource for how to get your Python code to run as a service by the operating system. All right, your final step. Figure out who can you call when you're out of town and there's water in your basement.